Welcome class. So in last class, the last topic we have studied was echo. And in last class, we have learned that if you are standing away from a very large mountain, 17.2 meters away from a very large mountain, then you will be able to hear the echo because we need zero point 0.1 second gap to hear one echo. Now we will continue from the echo. The distance will change with the temperature of air. The distance which we learned that we have to stand around 17.2 meters away to hear an echo can get changed when the temperature of air will change, because we know that as the temperature increases, the speed of sound increases, and if the speed of sound increases, we need to adjust the distance to hear the echo. Echo may be heard more than once due to successive or multiple reflection. You can hear multiple echoes due to multiple reflection of sound. For example, the rolling of thunder is due to successive reflection of the sound from number of reflecting surface such as cloud and the earth. So it's a cloudy day and this is our earth, okay? And two clouds strike and you hear a thunder noise, and this thunder noise strike to the land and again reflect back to cloud and again come to land. So you will hear multiple thunder noise. Okay, so it is the example of multiple echoes. Is it clear, class? From multiple echoes, we will learn about a new topic named reverberation. Reverberation. Reverberation means multiple reflection of sound. Okay? Multiple reflection. Let assume you are in a very large empty hall. Okay? Very large but an empty hall. When you say something in that hall, you will hear multiple sound of yours. Why this multiple sound of yours come in that room? Because in that room multiple reflection take place, and this multiple reflection is called as reverberation. A sound created in a big hall will persist by repeated reflection from the wall until it is reduced to a value where it is no longer audible. Okay, in a big hall, you always hear a multiple reflection or repeated reflection until that noise becomes zero or not audible. The repeated reflection that result in the persistence of sound is called reverberation. The repeated reflection of the sound is called reverberation. Clear, class? In an auditorium or big hall, excessive reverberation is highly undesirable. Okay? In a big auditorium and in big hall, if excessive reverberation take place, then you will not clearly able to hear what a person in the middle saying anything. So we always try to reduce that multiple reverberation. And how we do that? To reduce those reverberation, the roof of the wall or the auditorium are generally covered with sound absorbent material like fiberboard, rough plastic, or draperies. Okay. So to avoid those multiple reflection, what we do, we generally cover the walls so that multiple reflection don't take place by plastic or fiber boards. The seat material are also selected on the basis of their sound absorbing property. We also don't want that those seat also give multiple reflections, so we also select those material of those seat uh, so that those material can also absorb the sound and we will not get any reverberation. Now let's solve one example. Example is a person clapped his hand near a cliff and heard a echo after 2 seconds. Okay, okay, and there is a cliff. Person, okay, claps and hear his echo after 2 seconds. What is the distance of the cliff? The person if the speed of sound is taken to be 346 meter per second. So we have given the speed which is 346 meter per second, the time period 2 second. From these information we can easily calculate the distance and half of the distance will be the distance between that cliff and that person. Is it clear, class? Is this question clear? A person claps his hand near a cliff and hear a echo after 2 seconds. We have found out that the speed of sound in the air is 346 meter per second. We have to find out what is the distance between that cliff and that person. How we can calculate that? We have already given 346 meter speed and time period is 2 seconds. 2 seconds means the time which the sound travel from this person to that cliff and return back to him. We have to calculate what is the distance between that cliff and that person. And how can we calculate that? We know that speed is equals to distance divided by time. So we will first calculate the distance. That distance will be the distance taken by the time to first go from that person to that cliff and then return back to that person. So we will do half of that distance and we can easily calculate how much distance is between this person and the cliff. So let's see its solution. So speed of sound is 346 meter per second. Time period is 2 seconds. Distance will be velocity into time, which is 692 meters. So in 2 seconds, the sound wave travel to that cliff and then it return back. So we have calculated the distance sound wave has traveled. And now we have to calculate the distance between that person and cliff. And what will be that distance? That distance will be the calculated distance divided by 2. And we have calculated the distance which is 692 meters divided by 2. It will be 346 meters. So the distance between the cliff and the person is 346 meters. I hope this question is clear to you. Now let's move to reverberation. The next question is an echo is heard in 3 seconds. Time period is 3 seconds. What is the distance of reflecting surface from the source given the speed of sound is 342 meter per second? A echo is heard by 3 seconds. It is same like previous question that echo is heard after 2 seconds. We have first calculated the distance, then we have divided the distance by 2 because distance will be the half of the distance traveled by the sound. So again, we will first calculate the distance. Distance will be the velocity into time. and then we will divide distance by 2 to find out the distance of the reflecting surface from the source. I hope this question is also clear to you. The explanation is clear to you. Now let's see the solution. The speed of sound is 342 meter. Time is 3 seconds. We have first calculated the distance, which is 1026 meter. Using the formula, distance is equals to velocity into time. Okay, so distance is clear. Now we have to calculate the distance between reflecting surface and the source. It will be distance divided by 2, which is 513 meters. Because sound wave has taken twice the distance. First sound wave go from source to reflecting surface, then it returned back and it take 1026 meter. So this distance will be 513 meter. So the distance between reflecting surface and the source is 513 meters. Now we will begin the next topic. The next topic is use of multiple reflection of sound. This multiple reflection of sound can be utilized in many ways. Okay, and now we will learn the use of this multiple reflection. First use is megaphone. Megaphone or horn or musical instruments like trumpets all are designed to generate multiple reflection and spread loudly. This is the diagram of megaphone. You speak and what will happen, your voice will get multiple time reflected and then it will generate louder noise. Similar is the function of horn. In this curved tube, sound wave is getting reflecting multiple times, and when the sound wave it come out with a louder voice. Is it clear, class? So these are the uses of multiple reflection. We can speak louder using these multiple reflections. In these instrument, those two instruments which I showed you, megaphone and horn, in these instrument, a tube followed by a conical opening. In megaphone, for example, a tube is followed by a conical opening. The sound is getting reflected many times and move in forward direction towards the audience. A stethoscope. So whenever you visit a doctor, you always see a device on their neck with long pipe from which they check your heartbeat and listen the sound of your heartbeat in the ear. That device is called as stethoscope. Stethoscope is a medical instrument used for listening to sound produced within the body, mainly heart or lungs. Stethoscope sound of the patient heartbeat reaches the doctor ear by multiple reflection of sound. Multiple reflection of sound. Okay, this is a stethoscope. So stethoscope has very thin pipe, and in this pipe multiple reflections take place and reaches the sound of your heartbeat or your lungs to the doctor's ear, and from that sound doctor can identify that you have any sickness or not. Generally the ceiling of concert hall, conference hall and cinema hall are curved. Okay, the ceiling of cinema hall, any Concert hall or conference hall is curved so that the sound will get reflected and reach to the all corners of the hall. This is the diagram. Okay. We made the all those halls in curved shape so that noise can reach to every person in each corner. Sometime a curved soundboard may be placed behind the stage. Sometime a curved soundboard also placed behind the stage so that sound after getting reflected from the soundboard can spread all in the hall. Okay. This is the diagram of the curved ceiling of the conference hall or cinema hall. And this is the diagram of the soundboard which is placed uh, behind the stage so that the sound gets reflected and reach all the corner of the hall. Okay, this is the diagram of the soundboard. So these are the uses of multiple reflection of sound. Now let's solve sub question. Question number 1. Why are the ceiling of concert hall curved? And now you know the reason. So that sound get reflected and can get reach every corner of the hall. Correct answer is the ceiling of concert hall are curved to spread sound uniformly in all direction after reflecting from the wall. Is it clear, class? Now next topic is range of hearing. So we know that frequencies are of many time, but our ears can hear some specific frequency in some range. So the audible range means the frequency which we can hear. Audible range, frequency which human can hear is from 20 hertz to 20,000 hertz. Okay, the audible range of sound for human is in it has a range of 20 hertz to 20,000 hertz. Children under the age of 5 or some animals such as dogs can hear up to 25 kilohertz of frequency. 20 hertz to 20,000 hertz is the hearing range or audible range of human. Children under the age of 5 can hear up to 25 kilohertz. As people grow older, their ear become less sensitive to high frequency. Okay, so older people cannot hear higher frequency sound. The sound frequency between okay, so 20 hertz to 20,000 hertz is our hearing range, audible range, hearing range. We can hear the sound between these range. If any sound wave which has frequency less than 20 hertz, then this type of sound is called infrasonic sound or infrasound. Infrasonic sound or infrasound. If we could hear infrasound, if we are able to hear infrasound, then we will be able to hear the vibration of pendulum as we hear the vibration of wings of bee. We are able to hear the vibration of wings of bee, but if we are able to hear sound less than of 20 hertz, then we are also able to hear the sound of the vibration of a pendulum. Okay, class? Rhinoceros commute using infrasound, a frequency as low as 5 hertz. Rhinoceros have very nice hearing range, okay, and they can hear infrasounds and they also communicate by using frequency of low as 5 Hz. Whale and elephant also produce the sound of infrasound range. It is also observed that some animal get disturbed before earthquake because they are also able to hear those infrasound range which humans are not unable to hear. That's why some animal can detect earthquake more faster than any device human can make. Earthquake produce low frequency infrasound before making shock waves, being which possibly alert the animals. Okay, so earthquake first produce infrasound, then it produce main shock wave, and animals are able to hear those infrasound. So animal already get alert that any earthquake is about to come. So we have currently learned about the hearing range. 20 hertz to 20,000 hertz is our hearing range. Less than 20 hertz is infrasound, and higher than 20,000 hertz is known as ultrasound. Okay, frequency greater than 20,000 hertz are called ultrasound frequency, ultrasonic frequency, or ultrasound. Ultrasound is produced by some animals like dolphins, bat, porpoise. Okay, these are the example of some animals which produce ultrasound frequency. Moths of certain family have very sensitive hearing equipment. These moths can hear high frequency. Twists of the bat are known when bats are fly nearby. They are able to escape capture. Rat also play game by producing ultrasound. So animals produce ultrasound. We have learned that. Now hearing aid. People with hearing loss may need hearing aid. Some people are not able to hear. Okay, so they require hearing aid. And hearing aid is an electronic battery operated device which are installed in your ear. The hearing aid receives sound through a microphone. There is a microphone from which it receives sound, and that microphone gets converted into sound wave. Okay, so here electrical energy is getting converted into sound wave through a device. These electrical signals are amplified by an amplifier, and the amplified electrical signal are given to the speaker of the hearing aid. The speaker convert the amplified electrical signal to the sound and send the ear for clear hearing. So uh, so hearing aid is a some people loses their ability to hear, so they use hearing aid to hear, and hearing aid is an electronic device operated by battery. The hearing aid receives sound through microphone, and microphone converts that electrical energy into sound energy. Microphone convert that sound energy into electrical energy, and electrical energy or electrical signal get amplified by an amplifier, and that amplifier uh, gives signal to the speaker of hearing aid, and the speaker convert that amplified electrical signal to sound and send it to other person. So let's solve some question. Question number 1 is, what is the audible range of average human ear? What is human audible range? And we have just learned that the audible range for average human is between 20 hertz to 20,000 hertz. This is our audible range. 20 hertz to 20,000 hertz. Any sound less than 20 hertz cannot be heard by us, and any sound greater than 20,000 hertz is not audible to human ear. Is it clear, class? Clear. Question number 2. What range of frequency associated with infrasound and ultrasound? So we have just learned that frequency less than 20 hertz is infrasound and frequency greater than 20,000 hertz is ultrasound. So these are the range of infrasound. Less than 20 hertz is infrasound, greater than 20,000 hertz is ultrasound. 20 hertz, 20,000. Okay, so our next topic is application of ultrasound, and we will learn about this topic in the next class. In today's class, we have learned about echo, reverberation, then hearing range and hearing aid, and solve some questions related to it. I hope today's class is clear to all of you. Thank you so much.